Hey guys, let's take a look at the graphs of nonlinear functions. We've done graphs of linear functions, right? I mean, you know, the equation y equals mx plus b. We've done tons of those, right? Look like y equals, I don't know, 2x plus 5 or something like that. Remember that? You're a babysitter. You get $5 just for showing up. You get $2 per kid. How much money are you going to make? Well, it depends on the number of kids, right? The money you make depends on the number of kids, okay? There, of course, if you're babysitting them, they're screaming and yelling and, you know, crying and stuff like that and all that. Okay. All right. How does it, we can rewrite it like this, of course. Remember, every time you see a y, you can go, oh, f of x equals, you know, I don't know, 2x plus 5 or whatever. Same thing, right? Okay. This graphs as a line, as we know, right? If we go, oh, okay, you know, if, you know, no kids show up, then you get 2 times 0 plus 5, so no kids show up, you get 5, so it's there. If, let's say, 3 kids show up, you get 2 times 3, $6 plus 5 is 11, so 3 kids show up, way up here at 11, you draw the line, and that's completely, you draw it like this, there you go, something like that. That's your linear function. We're going to do nonlinear functions today, okay, so non-lines, so this is a couple of these. We're going to do the basic form for a quadratic equation. We've done this before. We've got ax squared plus bx plus c equals 0. And don't make this too complicated. That just means we have one unknown, x. And we have a certain number of x squared, a certain number of x's, and some constant, and it equals 0. Okay. If function, we're going to kind of do like this. We'll go, you know, y, you know, instead of y, we can do f of x. We can go, you know, equals ax squared plus bx plus c, and don't get too caught up in that. That just means, you know, y is going to equal some x squared. We might have an x, we might have a c, and so on. And we're just going to see these. And I want to remind you too, anytime you see a graph of any kind and you go, oh no, I can't picture what this is, just start putting in values for x and see what you get for y, and just start drawing them on the graph and see what you get. And eventually, you know, try 0, try positive numbers, try negative numbers, and then see what you get. And then eventually you'll kind of see some shape forming. And if you need to, that'll kind of help you keep going if you forget one of these. Okay, well, let's look first. So you need graph paper. And so pause it and grab that if you need to. All right, this is a quadratic function graph. We call this a parabola. And we've done this before, you know, where you say f of x equals x squared or y equals x squared or whatever. We've done those kind of equations before. We haven't ever graphed one though. So we can actually graph it. There's a really simple version right there. And again, this would be the same thing. I mean, if you had this, for example, and you totally forgot how to graph this, if you went, you know, if you didn't remember, oh, you know, if I do y equals 2x plus 5, that means 1, 2, 3, 4, 5 is the y-intercept, and then the slope is 2 over 1. 1, 2 over, 1, 2 over. If you completely forgot that, how to do this, you would just start plotting points, right? Okay, well, same thing here. We're going to plot points first just to kind of show us what happens. Then we're going to get to a point where after weeks go by, you'll look at one of these and you'll kind of be able to visualize it in your head what it looks like without even having to graph the points. But let's just plop some points in there. Okay, well, if x is equal to negative 2, right? Well, what is negative 2 times negative 2? 4, right? So that's a point right here, negative 2, 4. So we got negative 2, 1, 2, 3, 4. There's a point right there. All right. Well, what if it's negative 1? If x is negative 1, then negative 1 times negative 1 is 1. So there we go, negative 1 and then 1. Okay. Well, what if x is 0? Then y is going to be 0 squared, which is just 0, right? So here's your, you know, there's another point there, right at the origin. If x is negative 1, well, I mean, excuse me, positive 1, my bad. 1 squared is 1. So we have, there's another point, 1 over, 1 up, boom. All right, what if x is 2? Well, 2 squared is 4. So I think you probably see what's happening here. If I go 2 over and then 1, 2, 3, 4. And if we were to do all these in between and all this, of course, you could probably figure out, you know, if x is 3, 1, 2, 3, it would be 9. In fact, if x were negative 3, it would also be negative 3 times negative 3 would also be 9. So what happens is, this is the shape of a parabola. And I'm not going to do it justice, but it looks kind of like a U and kind of keeps going up by, you know, exponentially going up like that. That is y equals x squared. If you look at the vertex is at the origin, the lowest point's at the origin. It goes up right here, and it just looks like that. And eventually, you'll just be able to recognize what these look like. Now, let me show you what happens when we kind of slightly adjust this equation a little bit, okay? We're going to do this. Y equals x minus 3 inside the parentheses and square the whole thing. Well, you know, it's going to look basically like y equals x squared. Y equals x minus 3 squared. It's going to change a little bit. Let's see how it does this, okay? First off, what numbers do you think we should plug in for x? I mean, it's up to you, but I'd make this as easy as possible for myself. In fact, I would do 3 right away, you know? Because if x is 3, then 3 minus 3 is 0. 0 squared, boom, there's a point, right? So 1, 2, 3, and 0, okay? Well, why don't we make x, you know, I'll make it 1. If x is 1, then 1 minus 3, negative 2. Negative 2 times negative 2 is 4, right? So we have another point, 1, 4. So 1, 2, 3, 4. There's your blues, okay? Well, if we went over and we kind of arranged it to where we had small, in other words, you don't want to put like 20 in here. Oh, 20 minus 3 is 17. 17 squared is 289. You need a big piece of graph paper there for that. But make these small numbers as we can. Well, we could also do 2. You know, what's 2? If we put 2 in for x, well, we would go 2 minus 3, negative 1. Negative 1 times negative 1 is just 1, right? So 2 over and then 1 up, okay? You probably notice if we did 4, you know, if we stuck in 4, 4 minus 3 is 1. 1 squared is 1. So 1, 2, 3, 4 over and 1 up. You can probably see what's happening, right? Let's do 5. 5 minus 3, 2. 2 squared, 4. So 5 gives you 4. So 5, and you can see kind of the symmetry here of this. And if you notice, this is exactly the same drawing as we did. Look at that. Last one is x squared. This one's x minus 3 squared. X squared, x minus 3 squared. Now notice, if it's a minus 3 squared, look what happens to this. You tell me what happens from this to that. It goes over, right? The vertex, the bottom was at the origin here. It goes over 1, 2, 3. So this is over the number of times that it has minus inside the parentheses. So there's a rule. In other words, if you saw x, if you had to graph y equals x minus, you know, say 6 squared, it'd be like this: 1, 2, 3, 4, 5, 6, like this, and then like that. And of course, what if you had this? Y equals x plus 5 squared. Okay, at that point, you'd go 1, 2, 3, 4, 5 over, and it looked exactly the same thing. So that's how that works. And again, if you ever got stuck on this, you could just go, I don't know what to do. I'll plug in negative 5, right? You would plug in negative 5 because that's the easiest thing to mess with. If you plugged in negative 5 for x, in other words, if x is negative 5, 1, 2, 3, 4, 5 over, what would you get for y? Negative 5 plus 5 is 0. 0 squared is 0. So there's your point. And eventually you'd draw something that looked like over like that. At some point, somebody did this hundreds or thousands of years ago and figured out the pattern, okay? That's the other type. Now look at this. Here's a different type. Now look at this right here. This is not the same thing as the one we did previously because it's outside the parentheses, okay? So let's see what happens here. Well, I think probably an easy number to pick would be, you know, 0, right? Because 0 squared minus 3 would be negative 3. There's a point for you, right? 0, negative 3, 1, 2, 3, okay? Let's try another point, make it easy. Let's try 1, let's try 2, you know, and that kind of thing, okay? So we got 1 squared is 1, minus 3 is negative 2. So 1 over, and then negative 2, boom. And let's try, you know what, I don't know, let's try 2. So 2 squared is 4, minus 3 is 1. So there's another. So 1, 2, and then 1. You probably see how this is working, how it's going to be symmetrical around this y-axis again. But let's try negative 1. Let's try negative 1. Well, what is negative 1 times negative 1? 1. Minus 3, negative 2. So negative 1, negative 2, and you probably see what's going on here. So, and there we go. It looks like that. And don't worry about drawing these perfectly, just get the basic shape. Okay, so here's the deal. Look at this one, that is x minus 3 inside the parentheses, and it goes over to the right 3. Okay, this time it's outside the parentheses and it goes down 3, right? Okay, so you could tell probably if this said, you know, x squared minus 5, if that were the equation, you'd go like this. You go, the 5 is the farthest point down. If you had x squared plus 6 or something like that, you know it'd be like this, way up here at the 6 going up like that, and so on. Okay, and that's the third type of that. This is interesting. Same thing except for one difference. What is it? Negative x squared, right? Okay, I mean, but again, make it as easy as possible for yourself. 0, negative x squared is still 0, right? So it looks like this. There's your first point, okay? We could try a 1. Okay, if x is 1, what's the opposite of 1 squared? It's going to be negative 1, right? So 1, negative 1. In fact, let's just try negative 1. What the heck, right? If x is negative 1, well, negative 1 times negative 1 is positive 1. And the opposite of positive 1 is also negative 1. So negative 1 and negative 1. You can probably see what's happening here, right? Okay, let's just try another one. Let's try 2. If 2 happens, then we have 2 squared, which is 4, but the opposite of that, which is negative 4. So 2, and then there we go. And of course, I'm sure you can tell that if negative 2 times negative 2 is 4, then the opposite is also negative 4. So it looks just like this. So a negative means that the entire thing is pointing upside down. In other words, this is exactly the same thing as y equals x squared, except for it's pointing, it's like it's, you know, positives up, negatives down. It just flips across the x-axis. Okay, and that's the x squared function. All right, the cubic function, this looks super complicated, but don't worry about it. Don't even worry about it at all. The f of x, of course, just means y. That means you have a number of x cubes, a number of x squareds, a number of x's, and a constant, possibly. We'll deal with the easiest form, so don't worry about any of this stuff. You just worry about this right here. And again, you know, let's experiment. In fact, if you want to pause it, go ahead, and with a piece of graph paper, just graph out y equals x cubed and stick in these numbers, see what you get for y, and then graph those on on the graph. Just go ahead and pause it and do that. Okay, well, I'm assuming you did that, so let's take a look. If x is negative 2, well, what is negative 2 times negative 2 times negative 2? Negative 8, right? So negative 2, and then all the way down here to negative 8, right? Okay, oops, did that. Oh, let's go back. Negative 8 is right there. Okay, good, all right. And of course, I didn't do that. That's 2 negative 8. So I need to erase that. Think. And here we go. Let's do it the right way, for heaven's sakes. And that will be negative 2 and then negative 8. Okay. Well, let's do negative 1. What's negative 1 times negative 1 times negative 1? That would be negative 1. Okay. So here's another one. Right there. Okay. 0, of course, cubed is still 0. 1 times 1 times 1 is 1, so 1 over and then 1 up. And then 2, of course, times 2 is 8, so and then like that. And what this actually, if you were to go do all the ones in between, you'd find this. Ah, that looks terrible. But like that. It kind of looks like this, you know, like that. So that's what you want. All right, let's just keep on. Let's keep that first one in there, even though it looks pretty ratty. There we go. Okay. All right, well, that's the basic function of y to the third power, or y equals x to the third power. So let's kind of switch it a little bit, right? Here we go. Y equals x minus 2 to the third power. Numbers we should plug in for x, well, I think probably we want to make sure we get 0s and 1s and 2s and easy numbers. Okay, so let's just do 0. 0 minus 2 is negative 2. Okay, so 0 and then negative 2 to the third power is negative 8, right? Okay, so 0, and then down here to negative 8. There we go. Okay, let's try, let's try 1. So 1 minus 2 is negative 1. Negative 1 times negative 1 times negative 1 is negative 1. So 1, and then think down there to -1. Let's try 2. 2 minus 2, 0. 0 to the third power is 0. So 2 over and then 0. Let's try 3. 3 minus 2, 1. 1 to the third power, 1. So 3 and 1 is our next one. You can see what's happening here, right? Let's try 4. 4 minus 2 is 2. 2 to the third power is 8. So we have 1, 2, 3, 4 over and then 8 up. So we have exactly the same shape, of course. Since it's to the third power, it's going to keep that basic shape, that's pretty horrific. Now look again, look very quickly here, all right? We've got the basic one, then we have boom, 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 boom. And the same thing happens, you notice. Way back here, where we had, x minus 3 to the second power, and it shifted over to the right 3 times because it was inside the parentheses. Well, look over here. We have the x minus 2 inside the parentheses, and it shifted over. Look, there's with nothing, there's the minus 2. It shifted over, and I should have hit that, that line in there better, but it shifted over twice, same kind of thing. Okay. All right, a slight variation. Let's look at this. Now the -2 is outside the parentheses, right? So let's try it again. And you can probably see what's going to happen here. Let's try 0, all right? 0 to the third power is 0. And of course the y is going to be -2 there. So 0, -2 is 1 point. There's 0, -2, right? Okay, let's try 1. Make these real easy numbers. 1 cubed is 1. Minus 2, -1. So 1, -1. All right? We could just keep going if you want to. Let's try a 2. Okay, 2 cubed is 8. Minus 2 is 6. So 2 over 1, 2, 3, 4, 5, 6. And we can see what's happening here. Let's try a -1. -1. So -1 times -1 times -1 is -1. Minus 2, -3. -1. And there you go. And let's just try -2 because we know what's going to happen. -2 cubed is -8, right? Minus 2 is -10, so all the way down here. And you see what's happening here. So, and then I kind of got it anyway. But again, you see what's happening. Look back here. Remember, if we did this -3 outside, the whole thing went down 3. Well, the same thing happens here. If we go -2 outside, the whole thing goes down 2. Instead of being at the origin like it is, it goes down 2 if it's outside. Okay, and don't worry about it. You'll get these after a while of doing these and looking at them. Okay, and of course, here's our favorite. The negative. Remember what happened here? If y is equal to -x squared, it kind of flipped over that x-axis. Let's take a look at this one. All right. Let's say if x is 0, of course y is 0. We know that, right? That's easy enough. All right. If x is 1, then we have 1 cubed is 1, and that's the opposite of that would be -1. So 1 and then -1. Okay. Well, let's try -1. What the heck? All right, if x is -1, we have -1 times -1 times -1 is -1. Then the opposite of that would be +1, right? So -1 and then +1. And let's try something like 2. We'll try that. So 2 cubed is 8. So -8 this would be. So 2 and then down here. And what the heck? Let's try -2. How about that? And of course, I'm sure you probably guessed this is going to be +8. So this and this. Now, if you notice, this looks, again, like it's done kind of a flip here. So there's the new one with y equals -x cubed. That's the original one right there. And it just has flipped across the y-axis this time. Okay. All right, that's the first two. We have 2 more to go. All right, square root function. All right, square root function. All right, f of x equals square root of x. In other words, y equals the square root of x. You can put it that way. All right. Well, let's plop some points in here, right? Let's just make it. Let's make it look prettier here. Y equals the square root of x. Let's make this nice and simple. Anytime you see f of x, just in your mind or on paper, if it helps you, just stick a y in there instead. Well, this is pretty simple right here. Okay. If x is 0, then y equals the square root of 0, which is 0. There you go. Little point right there. Okay. Well, if x is 1, y equals the square root of 1, which is 1, right? So, boom, there we go. All right. X is 2. What's the square root of 2? You know, that's not an integer. Let's skip that one for now. How about 4? If X is 4, what's the square root of 4? 2, right? So the point is 1, 2, 3, 4, and then 2 up. You could probably keep going. I mean, the square root of 5, yeah. 6, 7, 8, nah. The square root of 9, we got that, right? That's going to be 3. So 9 over, and then 1, 2, 3 up. This is kind of what's happening here. It's curving. Now, one thing that is not happening is that it's not going like, in other words, let's try to put X is, in other words, let's go to the left. X is negative 1. Let's put that in there. What's the square root of negative 1? Can't be done, right? We can't graph it. So it stops right here. There's nothing else that happens in the story. That's the basic graph for the square root function right there. Y equals the square root of X. There you go. Of course, if you went all the way over to 16, spaces to the right, you'd go up to 4, and you just slowly just keep building up. Okay? Now let's change it slightly. All right? Y, that's ugly. Let's make it Y. Y equals the square root of X plus 2. It's inside there, right? Don't forget that. Okay? Now here's interesting. Here's what's interesting. Okay, let's just say you did X is 0. Well, 0, then Y is the square root of 2. I don't know what that is exactly. We know what would work, though, at least. You could go, oh, if X is negative 2, look at that. If X is negative 2, then negative 2 plus 2 is 0. The square root of 0 is 0. So there's a point for you, right? Negative 2, and then nowhere. Just stops right there. Okay? Well, let's try, I don't know, let's try negative 1. Right? Negative 1. What if X is negative 1? Well, negative 1 plus 2 is 1. The square root of 1 is 1. So there you go. Negative 1 and then 1. Okay? Oops. Oh, I shouldn't have done that. Okay, there's your point. Ooh, I lost it. Where am I at here? Nope. Oops, I lost my whole thing here. Okay, here we go. So negative 1 and 1 we said was our point. Okay. So you could probably figure out that this is going to be like this. We won't bother to do a whole lot more. It's going to go like that. Now, look at the difference between this and the previous one. Look, you see that? Okay, it's underneath the square root function, so it just moves over. And of course, since it has a plus 2 here, it moves over to the left too. Now, let's say you had this. Y equals the square root of X plus 5. Can you tell me what that would look like? If this looks like that with negative 2 right here, what would this look like here? It'd look 1, 2, 3 over to the negative 5. It'd look like the same thing, right? Okay, let's say you had y is equal to the square root of X minus, I don't know, 3. Then you would have 1, 2, 3 over, and it'd look just like that, the same thing, right? Okay. And if you're not sure about any of these, just do a couple of quick plot points. X is this, Y is this, boom, boom. Okay. All right. The last part of this one is slightly different. And again, we'll make this an X, or excuse me, a Y. Y equals 2 plus the square root of X. You probably have figured out what's going to happen here, but let's just do it for the heck of it. Okay. Well, if X is 0, let's make X 0. X is equal to, or excuse me, Y is equal to 2 plus the square root of 0. Well, the square root of 0 is 0, plus 2 is 2, right? So we have a 0, and we have a 2 here, all right? Well, let's try and see if X is a 1. X is 1. What's Y going to be? It's going to be the square root of 1, which is a 1, plus 2, which is 3, right? So 1 over, and then 3 up, okay? And then you probably figured this is, you know, going like this. In fact, we could even say, what if X is negative 1? Well, that's not going to work. In fact, you can't even say negative anything because you can't have a square root of a negative number. So this is going to look exactly the same as the other ones, okay, except for with the 2 makes it go up, all right? Now let's say, for example, you had this. Y is equal to the square root of X minus 5. On the outside, what would that look like? Since this looks like this with an up 2, this would look like the same thing except for down 5, right? I think that's 5. 1, 2, 3, 4, 5, and then it just looked like that, same thing, okay? The last type of this is the opposite of the square root of X. So here you go, same old thing. And again, you can put in any numbers you want. Let's put in a 0. Let's put in, we know we can get the square root of 1, right? How about the square root of 4? We'll do the square root of 9. How about that? Okay. So if we put a 0 in here, we get a 0, right? Because y is equal to negative 0, that's still going to be 0, right? Okay, there we go. All right. Let's say you put a 1 in. Well, the square root of 1 is just 1, right? And the opposite of that would be negative 1. So now we have 1 and then negative 1, okay? The square root of 4 is 2. Then the opposite of that would be negative 2. So 1, 2, 3, 4 over, and then doink, like that. And then 9 is going to be 3 here, and then the opposite, that'd be negative 3. So over here we have 9, and then that's yeek, there we go. So you can see what happens here. This is like, oops, I missed that both of those points. Let's make them really big. There we go. Now I got them. Okay. So you can see what happens there. This is like flipped around the x-axis. So that's your square root function. All right, last one, and we're done. The graph of the absolute value function. Ooh, this is kind of weird. Absolute value function. And again, let's make this simple. Let's make it a y. That makes it look too complicated. There you go. Okay. You know what the absolute value is, right? Distance from 0. Remember that? Okay. Well, we know it's going to be 0 is going to be 0, right? That's easy. Now, how about a 1? Y is equal to the absolute value of 1. Oh, that means 1. Okay, so, doink. And then, oh, look at there. 2 is 2. So, hey, look at there. Oh, 3 is 3. And, yeah. Okay, you might think, okay, I got it. There it is. It's right there. Okay, you'd be half right. Because, think about it. What if x were negative 1? Y would be the absolute value of negative 1. What was the absolute value of negative 1? 1, right? So, negative 1 for x and then 1 for y. And then, oop, there's a negative 2 and a positive, and then you can tell what's going to happen, right? Well, that's a terrible straight line, but you know, it's like a V. That's the absolute value function. Okay, let's do the other version of it, and we'll make it a y. Y is equal to inside, there we go. You can probably tell what's going to happen, right? Can you guess what's going to happen before we even do this? Let's just try it, just for the heck of it. Okay, x is 0, so the absolute value of 0 minus 2 is negative 2, so the absolute value of negative 2 is 2. So we have a 0, boom, and a 2. Okay. All right, how about this? If x is 1, 1 minus 2 is negative 1. The absolute value of negative 1 is 1. So 1 and then 1. Okay, let's try a 2. If x is 2, 2 minus 2 is 0, and then look there. 2, and then of course we can go 3. You know, 3 minus 2 is 1, the absolute value of 1, so 3 is a 1, and you can tell what's going to happen here, right? Again, it's going to be like this, and it's going to be like that. Okay. The negative 2 inside that absolute value is going to move it 2 to the right. Okay, and just for practice, what if you had y is equal to the absolute value of x plus 4? What would that look like right there? Can you visualize it? Same exact thing, except this would be moved over to the left 4. And then it would look the same kind of V. There we go. Okay. Last part is the y is equal to the absolute value. Oh, excuse me. This is the third of 4. All right. You could probably guess this one too, right? Let's try it. Absolute value, let's say it's a 0. What's the value going to be? 0 and 2, right? So there we go. All right, oops. So it's going to be 0, 2. Let's say x is equal to 1. 1 plus 2 would be 3, right? So 1 over and then 3 up. And you can see if x is 2, then it's going to be 4. And don't forget your negatives. If x is negative 1, the absolute value of negative 1 is still 1 plus 2 is 3. So negative 1 and then 3, and then of course negative 2 and then 4, and it looks like that. Now your vertex is 2 up. And of course, let's say if you had something like this, y is equal to the absolute value of x minus 5, you'd be going 1, 2, 3, 4, 5 down, and then you do the same thing. Okay. All right. Last one is y is equal to the absolute value of negative x. Well, we can just put stuff in there. We know if x is 0, well then that'll be 0, right? Okay. Well, how about a 1? X is 1. Well, the absolute value of negative 1 is still 1, right? So there we go. All right. Okay, how about x is negative 1? That's still going to be the same thing. There you go. Look at there. Okay. All right. If you'd like to, look in your book. You know what I did? Hold on a second. This is a bit, I kind of goofed here. Hold on a second. This should have been outside. The opposite. That should have been on the outside. So let me rearrange that. I wonder why nothing was happening there. If you ever need to look in your book, you can look on N95 and check these out all the time if you want to check your answers. This is how I should have written it. But if, let's say, for example, a 0 and a 0, of course, that would be the same thing. And let's just go ahead and fill these in. 1, 2, and 3. And how about -1, -2, and -3? If x is 1, then that's going to be the opposite of 1, will be -1. So 1 and then -1. And then 2 would be, of course, -2. 3 would be -3. Okay, -2 and -3. Now, if x is -1, well, the absolute value of -1 is still 1. And the opposite of 1 is still -1. So this is going to go over -1, -1, -2, -2, and -3, and so on. And again, this is flipped around the x-axis. So that's your function. Okay. All right. So if they give you pictures like this, all right, a quadratic function, in other words, one like this, y is equal to x squared, would look like which one of these? And the answer is B, right? It's a parabola. Okay, that would be some kind of that would be like a negative x squared because it's pointing the other way, and it'd be moved over. Okay, how about matching these? All right, we have this, and don't forget you can always use y's here. So which one of these is the cubic function? And that's this one, right? Okay, how about the next one? We have an absolute value function. Which one does that look like? C, right? Okay, how about the square root function? That'll be that one, okay? And here's a question for you. What, yeah, it's that one, okay. Yeah, oops, it's that one right here. Okay, good enough. I figured you knew that one. All right, let's match them. You don't even have to know how to graph these. You can just look at them. Okay, so which one of these is the cubic function? Which one of these, A, B, C, or D? It's B, right? Okay, how about let's go K of x is equals the absolute value, and that's this one. Yep, okay. H of x equals 1 plus the square root of x. Well, the square root function looks like that, okay? And the quadratic function, of course, looks like this right there. Okay, that's it. All right, you have practice problems. All you need to do is match those, and you can check your answer key for that one. But you know what? I guess we can do them together. Not that big of a deal, okay? You can pause it if you want to. Okay, let's look at A. The first one for A is going to be the square root function, number 1. Number 2 will be the cubic. Number 3 is the absolute value. And number 4 is the quadratic. Okay, pause it if you need to again for B. Okay, B, the number 1 is the quadratic function. 2 is the square root function. 3 is the absolute value. Yep. And 4 is the cubic. Yes. Okay. All right. Hope that made sense. Make those shapes. Make sure you know the shapes, and then keep on. We'll do more of that in Algebra 2. See y'all.